Well, welcome back to the Just Build Baby studio. This is the BuildX Podcast. We're going to explore everything better about building better homes, smarter spaces, and everything residential construction. I'm your host, Buzz Artiano. We're excited to have Andrew Popielarski here today in studio. Andrew is a senior home energy rater at Home Energy Raters. That's a mouthful. With 12 years of experience in home energy. Welcome to the studio, Andrew.
Thanks for having me, Buzz. Happy to be here.
Yeah, absolutely. So if you wouldn't mind, I did read your bio and thank you for that, but if you could take us back how you got started in this industry and currently where take us through a timeline of how you started in this industry to where we are today.
Yeah, so originally I moved to Massachusetts in 2013.
From
Philadelphia.
Okay.
And when I lived in Philadelphia, I did indoor air quality testing for 7 years, and I also did work on LEED buildings as a LEED Green Associate. Then when I moved to Massachusetts, I ended up meeting Bruce Torrey, who at the time was the owner of Home Energy Raters. And although it was different from indoor air quality testing, there was some similarities, and they at that time needed somebody to do testing on Cape Cod.
There you go.
And that was how I got involved in it at that point. And since then, after probably myself, I've probably energy modeled over 2,000 homes on Cape Cod over those last 10 years. I also took on the venture of building my own home, new construction in 2018 in Yarmouthport. And then 2 years after that, I built a slightly detached two-car garage with in-law suite for my mother. So that was
quite an early ADU.
Yes.
An early ADU.
So that was quite the learning experience.
Okay.
And doing that along with helping builders do all these energy models has really taught me the importance of being able to build on a reasonable budget and build so that the home performs properly.
Right.
And that can be the tricky piece of the puzzle.
Yeah, so I'm not sure how long ago I started working with Home Energy Raters, but it's been a long time now. And one of the things I appreciate about working with your firm is that they are watching, the budget, if you will, saying, we need to meet this energy code, and based on your building and your orientation, et cetera, this is how you can get the most energy rating for the least amount of budget and still do it properly. And that's one of the things I really appreciate working with your firm, and that you're not afraid to call me up and said, why are you using this window? If you use this window, we can change all these other things and it's going to make a big difference. So I appreciate that. I've always appreciated your feedback. Obviously, you and I have met many times and talked on the phone a bunch, and I always appreciate your candor and the way you get to the point and say, what are you trying to do? This is how I think we should do it. Here's why. Mm-hmm. And I really appreciate the fact that you always explain it. So that's why I decided to have you come in today. And I think everybody's going to learn a lot. I know I'm sure going to learn a few new things, right? Because I'm always learning. And especially about energy rating, where the codes are changing, and they just changed, and they changed them back, and we're going to get into that. So 2013, you started working for Home Energy Raters. You've been there ever since. So what's that, 12 years now, right? And obviously you like it, right? Yeah. And so tell us about what you currently do, and then we're going to get into all things energy code.
Yeah. So most of my work nowadays is not doing very much testing. It's generally working with the builders on the front end, and now that even like the architects and engineers in multifamily projects, so that we can design these buildings to have all the equipment they need, the ERVs, the right heat pumps, the right heating hot water equipment, right? So that we meet this new energy code, which can be a challenge, but then at the same time, making sure that the building's going to function properly.
Yeah, it's one thing to meet the code, it's another thing to make it so people want to live there.
Exactly, and comfort,
minor point.
Right, good indoor air quality.
Sure.
And nowadays you have kids that have asthma, people who have all kinds of immune compromised
100%.
situations.
Yeah, we were just talking about that in the previous podcast. So.
Yeah, and that's where I always say that every different build has different goals, right? And some builders I'll talk to, I'm talking to them and their customers, say, hey, what's the goal of this project? They're like, oh, we want this beautiful house on the water and X, Y, and Z. We want gas cooking and gas equipment, whatever. And then I say, okay, if that's the case, then this is kind of what I think is your best path to achieve that and meet this code. Because now our code's gotten so strict that you kind of can't just say, as a traditional builder, like, all right, I'll just do what I've been doing for the last 10 years.
It's not the old days. So that brings up a good point. So your advice in this, and so wouldn't say I learned it the hard way, but I was a little slow to pick up on this, was as soon as I have a design that I'm thinking about, I need you involved to start in that process so that you can offer, value engineering and thought to behind what's gonna happen with that structure. It's, like you said, it's not like the old days where we're building the same model over and over again. We've kind of perfected it. And, the houses were obviously were a lot less sensitive to, the air leakage was just assumed, right? And we didn't try to control it. We just said, listen, we're gonna build a tight house, but obviously some of those were probably 3, 4, 5, 6 air changes an hour, even with modern construction. So now we're getting down into the 1 or sub 1 air changes. It's a totally different conversation, right?
Yep.
So I'm gonna start with my favorite subject, which is accessory dwelling units, and then we're gonna go to larger houses that have much more complex requirements, right? You can only get in so much trouble for a 900 square foot house, right? So one of the things we talked about, and obviously our previous guest, we hit on that, was, and again, everything I'm saying is generalized, right? There are specific instances. What I'm about to say is not true. So full disclosure, right? So this is not the Bible. My strong encouragement, if you're listening and you have a question, Andrew's contacts are going to come up on the screen. He's the expert. Reach out to him. We're just having a conversation about my experiences, right? So full disclosure on that. And we're filming this in May of 2025. If someone's watching this 2 years from now, it may be a different answer, right? So these things are evolving all the time, as you know, right? And I'm sure you've had a headache trying to keep up with it,
Yes.
right? So when I started my ADU journey, and you and I had a conversation, we were all electric. We had to be all electric, right? No more gas, no more oil, no more propane, 100% gas, electric. And was it about a month ago that they said, we're gonna change the home energy rating score. So we're gonna go from a 42, 45 to a 52, 55? Is that what happened?
Yeah, so basically what happened is July of 2024, the stretch codes adopted the latest version of the energy code with mass amendments, and that specified that all new construction buildings be a HERS 45 if they're all electric, a HERS 42 if it has propane or gas in the home.
Mixed fuel, yeah.
And one of the changes that the DOER announced, and it was I think February 14th that they made the code change, is that ADUs would now be their own category. So they would not be HERS 45,
So
42.
February 14th.
Yep.
Valentine's Day.
Valentine's Day, yes. And is that they said ADUs were in love with you, and
Yep.
you therefore only have to be a HERS 55 if it's all electric, HERS 52 if it's mixed fuel, which is, in my opinion, a more reasonable HERS score to achieve, especially if you're trying to build affordably.
Right. And a small structure.
And a small structure.
Right, because it does, as you know, if the windows and all that count towards your rating. And in a small structure, you want, my ADUs have a lot of windows, right? Big windows. You have a lot of, your ratio to windows to wall area is really high, right? Or really low, depending on which way you slice it. But there's a lot of windows per the wall area, right? And so that affects your score.
Right.
Right?
Yeah, is that generally in a lot of these cases, the regular insulated wall cavity ranges from an R20, which used to be relatively standard, where now to hit the HERS 42, a lot of these houses are going to an R37 wall.
Right,
So
which means what, 2x8s, or they're doing the foam on the outside?
They're actually staying 2x6. Most of the builders that I talked to about this, they could do 1-inch exterior and then stay R20 in the cavity, but a lot of them go to R37 by doing 5 inches of closed cell foam in all the walls. Now that can be an expensive insulation package.
Yeah. And as we spoke earlier, and the previous guest, that does leave a little gap between the back of that closed cell and the drywall.
Right.
Right.
Yes,
Which
you have that air gap in the front.
That gap can be problematic.
And what I've seen over the years in doing a lot of insulation inspections is, for whatever reason, and I'm not sure if it's during the curing process or if it's through the first couple season changes.
Yeah.
But I've seen a lot of closed cell foam
Pulls off the studs.
pulls off the studs and or the rafters.
Yep.
And the big problem with that is once you get the house to a really tight envelope, in the winter, you're going to have naturally higher humidity, which
Sure.
makes the house feel really comfortable. But if you have a little void in the wall or on the roof line, that warm, humid air will go to
right
that
to
spot, touch the sheathing, which will be
condensate.
cold enough to be a dew point, turn to water, and just be dripping there all winter long.
Yeah, yeah.
And I've even seen it a lot of times in the roof line where they'll overspray the rafters, which is what I recommend to people.
Sure.
And in this case,
Co-
they did.
cover them up so you don't see them at all.
Right. But in this one case, the ridge was made by 4 16-inch Veralams. So all the rafters were 2 by 10. They were all covered. But the 4 Veralams weren't.
And it cracked at the ridge.
And it was just dripping water from between the Veralams. And so these are the things you see that you're like, oh, building tight is great, but not if you miss a couple spots. You can
It's
have
the details that eat you alive.
some really serious moisture issues.
Yeah, yeah. So that's interesting. So again, what I've been doing lately is the hybrid, which is the 2 inches of closed cell and then filling the cavity the rest of the way with the open cell.
That's
Right.
what I think is best practice, especially because that open cell expands so much, and then they shave it flush.
Right. You don't
I
have that air gap.
I don't see those voids.
Right.
So that makes me feel a lot better that
I like the way it fills around the electrical outlets better too.
Right. And if, God forbid, you do have to get to something, you can just rip it out with your hands
yeah.
rather than have to hacksaw it.
Right.
So pluses and minuses, right?
Yeah, yeah. There's trade-offs to everything, and you
Right.
want to find the most, the least problematic system and still fit inside a budget, right?
Right, exactly.
Yeah. So and then so that's interesting. And then we just had this discussion, but we'll have it again. So what we've determined, because we're kind of forced into crawl spaces in most areas, that's what I started this conversation with earlier, is that what I've decided is we do a concrete wall crawl space, leave the dirt exposed, and then when the structure's done, we have the insulation company come and he sprays 2 inches of closed cell down the rim joist, across the top of the concrete foundation that's showing, down the face of the concrete, and across the floor, back up and tie it all into one big, closed cell.
Yep.
And so, to me, that seems like the best option that we have right now.
Yeah, I would agree. I think that is probably the best option for doing an insulated crawl space. And that way, any ductwork that you have down there.
Yeah, whatever's down there is in
Inside-
a conditioned area.
Inside the
Right, and then
envelope.
my next thing that we just talked about here is I'm gonna future-proof that, so not all places have radon, but I'm gonna stick a 4-inch pipe into a stone pit and run that up through the roof
Yep.
as its own vent, if you will, and let that just be just from the chimney effect is gonna pull any, because if there is radon or whatever's under there, I want a way for it to get out.
100% path of least resistance.
Right.
That's why, like you said, use the high pound spray foam.
Yeah, 3
cover
pound.
the whole slab, and then that tube is going to make it so that any gas that's underneath that slab,
All moisture.
right, it's going to go up the tube and out.
Right. Yeah,
'Cause
yeah.
it's not going to want to fight through the foam or try
Right.
to find another path. It goes
Right.
right up the.
Yeah, I like that. So that was a good session with Jesus earlier, and I really, that reinforced a lot of ideas that I had. So we've dealt with the crawl space. We've dealt with the walls. Now we're in the ceiling, right? Now there's a catch-22, right? So now we have a crawl space. Do we put our equipment down there, which is limited height, right? If we've only poured 42 inches or 44 inches, right? Or do we put it in the attic,
Right.
right? Because we still, whatever it is, it's going to have to be serviced at some point, right? Things break,
Yep.
right? And so do we want, as a technician, does he want to crawl down in the crawl space, or does he want to go up in the attic? My inclination is to lean towards the attic, right? But my issue is, now let's pretend that I do an R60 blown in the attic, right? And I've terminated properly, I have my proper vents, I've got a ridge vent, I've got all that working correctly, inlet, outlet, etc. And I've done my proper air sealing, all that. But now I have a piece of equipment that's sitting in an unconditioned environment, and it's either freezing cold up there or it's 140 degrees in the summer, and I'm trying to make electricity, and this is absorbing that heat while it's trying to make, not electricity, it's trying to make air conditioning, cool air, but I'm sticking in an environment where it's fighting to make the cool air, right? So now what?
So I generally tell people that I do not like having any equipment, gas or electric, heating and cooling equipment in an unconditioned attic. I think that it creates multiple issues. One is the service factor, right? And what these R values need to be is likely you're going to need something close to an R60 blown in cellulose in your flat. So now you got 15 inches of cellulose up there. So who's going up to change the filters, right? And is that thing, burying the unit? Did you have to
even
build
if you
it up?
build a platform, there's still going to be an access point that's not going to have R60.
Right. And then like you discussed, now it's 120 degrees all summer long in that attic,
Right.
and this unit's trying to make air conditioning.
Correct.
And then vice versa, in the winter, it's 10 degrees or negative degrees, and it's trying to do heat. In my opinion, the performance of that piece of equipment is going to be significantly worse because of those conditions you're putting it in.
Yeah, 100%. And what I've noticed too with these heat pumps is they don't have the oomph that a fossil fuel does, right? It's not a gas pedal where you can leave the house at 55 degrees during the day and then you come in, okay, I've been gone all weekend, you crank it to 65 and 10 minutes later you're warm. Heat pumps don't work like that.
No, they were slow and steady.
Yeah.
They like a really tight envelope, and they just want to run slow and steady all the time.
And that's why they're efficient.
Right. And the other issue I see a lot with systems that are in unconditioned attics is that in the summer, right, when it's 120 degrees and 90% humidity in the attic,
Right.
they insulate all the ductwork with R8.
Yeah, it's tiny.
But when it gets to the boot that's
Yeah.
in the ceiling,
It's a metal transition.
yes, that metal transition just drips water all summer long.
Yeah.
And usually it's getting absorbed and just makes the cellulose wet up there.
Yep.
But after long enough, it can get bad enough that now you see a water stain in your sheetrock.
Yeah, or mold.
And mold, and right, and it's starting this issue. And that's another reason where if that was the way we were insulating this house, I would 100% say I would want the equipment in the crawl space.
Okay. So I agree with that, and the one that I'm doing in Plymouth coming up is going to be in the crawl space. And I'm also, as we talked about, I'm just going to transition and talk about the other mechanical system. So we have our hybrid electric water heater. Now, we talked about now we can do mixed fuel, and we'll get to that in an ADU. But right now, let's put, there's some pluses and minuses to that because it's a small building, right? So if we're doing a hybrid electric water heater, again, it's unfortunately they don't make in Europe. They do have ones where the water tank is detached from the heat unit, right? And you can actually put that outside like a condenser you would see, and then the heat unit is in the basement, but they aren't available here right now. I think they will be soon.
There are actually a couple that are now available.
Okay, so that's new.
Yeah, the Senko 2 is a product that has been available in the U.S. that is the outside heat pump unit and the indirect hot water tank.
Okay.
The issue with them is that it's about $5,000 for the unit.
Wow.
So we're a traditional.
So there's something available, but it's not quite affordable.
Right. But now that the new refrigerant has changed to this R32.
Right, which has propane in it?
Apparently,
Yeah.
it's apparently slightly flammable, but for the energy
That's
model.
a different discussion.
Right. For the energy model, we have seen better efficiencies, and specifically like in your situation with these ADUs, the hybrid heat pump hot water tanks has been an issue for ADUs and small apartments because of the space and the air movement that they do. So I have a couple builders that are using this new product that's just come out this year. The one is made by a company called Hisense, and it's a heat pump outside unit that does the heating and cooling, and it does an indirect hot water tank.
Interesting.
Yes. And
all in one unit.
All in one, and it's a double stacked outside heat pump unit.
Oh, I've seen those. Yeah.
Right. And usually that's for like
so they're
a
quite
bigger
tall.
system.
They're quite tall.
They are.
Yeah.
But now to just have that and do the hot water and you don't have the fan running in the unit is a big benefit. Plus the efficiencies are really good. And I think you're now minimizing your equipment purchases as well.
Yeah, and you don't need to find a home for that water tank.
Exactly. And you can get a 40-gallon one, you get a
Yeah,
120-gallon one.
Okay.
And the way the technology was explained to me is that
and what is the brand name?
Hisense, and I've heard LG also makes one as well now. But
so we need to get them in studio, have
yeah.
that conversation.
Yeah, I think it's
I'm actually going to bring you to that one, because
Yeah.
I'm going to need you for that one.
I'd love to, because that's been an ongoing issue.
Actually, I'm going to make you quarterback it.
It's fun. So many builders I talk to about their multifamily projects, and you're sitting there and you have a 200-unit building.
Yeah, that's a lot of water heaters.
Now you have 200 heat pump hot water heaters. That is going to change the
Yeah, yeah.
overall comfort of that building
Sure.
drastically. You now have all these units sucking heat
Yeah, yeah.
and moisture
And
out
they
of the
make
air.
noise too.
Right, and they make noise. And now it's in a 600 square foot apartment. The person
Right.
hears this thing running
Yeah,
next
yeah.
to their bedroom. It's a problem. But the way it was described how this new Hisense piece of equipment works is like in the summer when it's making air conditioning. You have all that added heat that usually just gets blown outside.
Oh, they're recycling it to make
It
the
goes
hot
right
water.
to the hot water.
Ooh, I like that.
Yeah, I was like, wow, that sounds really nice.
That's like a regen system almost.
Yeah. So, I mean, it sounds unbelievable,
Yeah.
but it's new, right? So we
Yeah,
gotta
who
see.
wants to be on the bleeding edge?
Right.
Well, in the meantime, until I figure that out, and again, that's why I explain to everybody. Everybody wants hard and fast answers about these ADUs between zoning and septic. I said, listen, there's a lot of uncharted territory here, and we just obviously discovered a new path to maybe deal with some of those other issues. But for now, we're going to stick with the tried and true, heat pump system and a hybrid electric water heater.
Yep.
And the unit I'm using is able to be ducted.
Yeah.
Okay, so my plan is to duct the inlet, hopefully down low by the back of the fridge, right, to pick up that waste heat from the fridge.
Yeah.
Right, and then take the cool air and duct that right into the crawl space.
Love it.
So that's the plan. That's what we're going to do over in Plymouth, the next one we're doing. So we'll do some video about that. And I think now that I'm talking about it, I want you to come to that house, and we're going to do a session once it's insulated.
Yeah.
And actually before we insulate, and then one after it's insulated. And we're going to walk it and talk about why we chose, why you recommended what we do to that unit based on the HERS report, and what the good, the bad, the ugly, right? And say, we could have done this, we could have done that. Why did we choose this? Why did we choose that? Right? Because there's a trade-off in all these things. Right?
100%.
Interesting. All right, so that's exciting. So I think for now, if we're forced to go to an attic, we really need to insulate the attic and do an unvented assembly.
That's what I recommend, that if we're going to have equipment in the attic, you make it a hot roof, so that way the equipment's inside the envelope. Then could allow you to have your ERV up in the spray foam attic, vent out a back gable end.
Yep.
Right, so you can hide the venting. And that's another.
So my concern with that, and I agree with you, and I did that a ton of times when we were using gas, right, mixed fuel, or indirect oil-fired, forced air system, right, hydro air, right.
Yep.
But now I have this heat pump, right, and it's slow to go, right, and it is warm, but it's not hot, right. And I'm nervous. I've got an ADU. I like 9-foot ceilings. So I've got a 9-foot ceiling, but now the ceiling's not insulated anymore. Now I've got to heat that whole attic and make my heat come down.
Yep.
So am I hallucinating that, or is that real?
I don't think it's that real, because when you spray foam the roof line, it makes that house like a thermos.
Okay.
And it's so tight that literally that attic will be like the same temperature as the living space, even with no registers up there.
Right, yeah, no, I know that.
Yeah.
I've been in them, but I'm just concerned that I'm going to, let's face it, every house has some leakage, right? So we have cold air coming in, right? And I just feel like the occupants are going to feel cool in the room, and the heat's all going to be stuck in the ceiling.
Yeah, and my biggest issue in my house that is all spray foamed, slab to peak, is it's too hot in the winter.
Interesting.
Yeah, because you don't realize these ACHs, they did a good job spray foaming it, and I was happy. And then we did the blower door, and it was 0.5 air changes an hour. So at the time, I'm like, fantastic, look how good a job I did. Wow, I'm really
high-fiving.
Yeah, woo! But then first winter, it's 76 degrees on my second floor, and I got the thermostat set at like 68.
Yeah.
And I'm going, what is going on?
It's all that hot air rising.
Yeah, and the fact that these heat pumps, right, I have one outside unit that runs 3 pancake units, one for each floor. But your finished basement has a very different temperature spectrum from your second floor. And one of these things I found out is that these heat pumps can modulate with their ECM motors, but they can't go down to less than 50% of the outside unit's capacity. So what I was having happen is your basement unit's calling for some heat, but that's only a third of what its capacity is. So there's an extra 15, 20%.
Right, and the only way it can waste it off is by turning on the second floor.
Yes, so it has to go to your off units and heats those coils up.
Yep.
And then when the fan chamber gets above like 86 degrees
Fan
for
comes
fire
on.
precaution, it comes on. So
Even if the thermostat's not calling.
Right, so that's what really freaked me out. I got the thermostat off up there, and I walk past, and I feel heat coming out, and I'm going, what is going on? So that was at the point when I then got on the phone with LG, and then I found all these things out.
Yep.
So now, since then, all winter long, the heat is off on the second floor completely. The first floor, I have it on fan only, and just the heat and the temperature set on the finished basement unit, all winter long.
That's phenomenal.
And it's still 70 degrees on the second floor regardless. So, I mean, it works out, but, you know, you live and you learn.
Yeah, and that's the whole point of these conversations, right? So that's good empirical knowledge that you would only know by doing that. Right? So the best laid plans of mice and men, right? And then you found out, now thankfully, you know, you had some adjustability built into the system, and, you know, if that had been one zone, you would have been in trouble. Big trouble.
And then it's just, you always have uncomfortable parts of the
Sure,
house.
Yeah. So, so if we're forced to go in these, so it sounds like, in your opinion, the best place is in the crawl space, right?
Especially if you're insulating the crawl space walls and under the slab.
Yeah, you're
like
making
that.
it a conditioned area, essentially.
Yep.
And we're dumping that cool air in from the hybrid water heater, and then we're doing an R60 or whatever in the attic, and we're getting those air changes down to 1.5, and we're adding in an ERV, which we're going to talk about in a minute. That's probably a pretty energy efficient unit.
Yeah, for sure.
Right? So now, I know we won't need, so what happened was, obviously, on February 14th, they, you know, loosened up or reduced the energy requirements for the ADUs, and now we've gone back to essentially to one code before this one, correct?
Yeah,
For
the level of what the ADUs are is what it was the code before.
Okay, and now we can, so that means we have the ability to do mixed fuel. So now we could have a gas stove, we can have a gas, we could be all gas if we wanted to, as long as the house is modeled correctly.
Yes, and you still could, even with getting to 42,
Yeah, I know, it's
you
tough,
would just
though.
maybe incur some added costs.
Right, yeah.
Right.
It was harder.
Right.
Right. This really opens up a lot of territory, you know, because I do have customers like, I'm fine moving an ADU, but I don't want to give up my gas stove.
Right. Well, you know where the 55 can come into play as a benefit with the ADUs is it can allow us to go to a resistant electric hot water tank if you wanted to, because the person had complaints about the sound of the heat pump tank.
So you could skip the hybrid water heater.
And still get to a 55, which in some of these ADUs, having just a little low boy 30-gallon tank
makes
is
sense,
all
right.
they
It's
need.
one person living there.
One bathroom.
Right, yeah, one person living there. Why do they need to be buying a $1,800 or $2,000 water heater when we get by with a $600 unit?
$600 and it does the job.
Right.
And that's some of these trade-offs, right?
Right, yeah, that's all. And that's why, again, it's important to get you involved early and to say, this is what our goal is, and then you say, and I will say this about you to your face, you're very creative, and you think outside the box, and that's one of the things I really like about you, because you're not like, no, this is the way to do it. You get, like, we talk through everything, like we're doing right now, and we say, what about this, what about that, what about this, and okay, I saw this new thing, we can do that, right?
Yeah.
And that's part of the process, and you have to iterate around these things. Listen, once you work on one, and you know, for me, I'm going to have 10 standardized models-ish, right? And once I've built, you know, the X1 2 or 3 times, I'm going to know what works, right? And those conversations with you are going to be minimized unless the people want to do something different. And I've already, you know, proven out that this is the most budgetary but the best system budgetary friendly, but the best system we can build.
Yeah.
So, but when you're building anything that's custom or different, there's a lot of conversations have to happen up front.
Yeah, generally I tell builders, especially if they want to take advantage of the options of cost engineering and some of their choices, is to contact the HERS rater before they purchase their windows.
100%. Yeah, because once you're locked into that, it drives a lot of decisions.
Correct.
Yeah, that it's the U value, correct? That
Yep.
drives that number.
U value, and then for our
Solar-
climate zone, the solar
solar
heat
heat
gain
gain.
being higher is a benefit. So that's where you can get some tricky choices where some window manufacturers have products that, like for Andersen, I think they call it their passive sun glass. And that doesn't necessarily cost that much more because it lets more sun in, but it raises the solar heat gain, which helps the energy model. And basically in a lot of these homes, I'm able to get builders to switch to that type of a double pane glass, and that prevents them from needing to go triple glazed, which is a huge cost increase.
Yeah, and honestly, looking through them, you can tell it's triple glazed.
Mm-hmm. Oh yeah,
the glass is clear, but you know the difference when you're inside, and they're heavy.
And in some of these homes, the window order's over $100,000.
Yeah, it can drive.
So now you add 50 grand to that, and whoa,
right. Yeah, it's definitely a needle mover. So. So I'm going to finish up with ADUs with ERV. Mm-hmm. So energy recovery ventilation system, right? Yep. Smaller house. Mm-hmm. In the beginning, we used to just be able to use the bath fan, mm-hmm. right? And it was rated to be our ERV, which really wasn't an ERV. It was just an exhaust fan that could run continuously, right? Right. DC motor. So now that we've gone back a code, can we just switch back to the bathroom fan and not need the ERV?
No, you need the ERV and or HRV are mandatory.
What is HRV?
Heat recovery ventilation unit.
Okay.
And I could explain where there's two different scenarios that I feel like should kind of dictate which one of those you'd be buying.
Yeah.
So for our climate zone in the Northeast, if somebody is not planning on having humidification added to their heating system, okay, then I think the ERV is the best choice.
Okay.
Because the difference between the ERV and the HRV is mainly that the ERV has a like polymer type of core that does the energy recovery and has its two channels that the air goes through. And that's where the energy recovery happens. But the ERV retains about 50% of the moisture in the air, where the HRV has a condensate line and a metal core, and it condenses the majority of the moisture
like a
off.
Distiller.
Right, so it dries, which can be great in our climate zone for the summer and the spring, but then in the winter it gets too dry,
right.
which
everybody's running around with lotion.
Right,
so
nose is sore, your throat's sore, walls are cracking in the new construction, floors are cupping, right? Yeah. All stuff that people want to prevent. But if someone's planning on having a humidifier added to their furnace or heat pump, then I think the HRV is the right piece of equipment. Because now that HRV is constantly taking moisture out of the air, but if it ever gets down to say 40 or 45%, you're going to add humidity back.
Got it.
So it gives you a lot of control to stay between 40 and 50% year round.
Right. So if we're doing a heat pump system, we're doing an ERV.
Usually if you're not adding humidifiers.
Right. So you can add a humidifier to a heat pump system.
Yep.
Interesting. I didn't even think of that.
Yeah, if it's a ducted system.
I learned something again.
Yeah, if it's like a ducted system.
Yeah, it makes sense, right? It's no different than having a furnace. You just add a humidifier on it.
Right.
Right. So ERV, so the latest ones I've been using that you recommended was the through-wall one. It's a 6-inch, and the ERV is actually in that tube, and then it's up high on the ceiling. So we have to use an ERV even though we've gone back to the old code.
Correct, and it didn't go back to the old code. It
just the HERS rating.
Changed the HERS score for ADUs.
The score changed, not necessarily what you need to do.
Correct. It's still the IECC 2021 with mass amendments, but they gave ADUs their own category.
All right. So we got a little push on that, and that allowed a little flexibility in construction costs. We still need the air changes per hour on the ERV.
Yep.
And then did the air changes overall on the blower doors change, or that's still what it has to be?
Generally, like 3 air changes is what you would need to get to the 55, 52. Okay. It's the 45, 42 where you need those really low blower door numbers.
Yeah. So, okay, so I think that's everything ADU. Now, one of the things that I've done on a couple houses that I've built recently, full-size houses, if you will, not ADUs. So the last ADU we did, we're going to talk about aero barrier now. So if you want to explain aero barrier, and then I'm going to talk about some scenarios. What is aero barrier? What is it? Where did it come from? Who does it? All that.
So I'll give you 2 different scenarios that most of the builders we work with use to get to a
No, but
one.
tell me what it is.
Oh, I will. Well, it's one of the options. I'll get there in one
Okay.
second. So the first one, though, is like a spray foam insulation package. And generally what I tell generically most homes, right, is that if they insulate the entire foundation and they spray foam to the peak, that house should be around 1 air change an hour. With that
Interesting.
type of insulation
So a hot
package.
roof.
Hot roof.
So spray down the sill over the top of the concrete.
Mm-hmm.
Even if they're not finishing the basement, right down to the basement slab.
Yep.
And then all the way up through the top rim joist, all the way up right to the ridge. No vented assembly on the roof, and obviously do the gable ends.
Yep.
Okay.
Exactly.
Now you feel like that's an automatic 1 on an air change.
Unless something was missed.
Yeah, yeah.
In my opinion, you should.
Assuming that the insulator found all the nook and crannies, and the builder didn't leave some boxes in the walls that no one can get to.
Right.
And all those things that do happen, right? We're going to be at a 1.
Yep. That's where, if they insulate it like that and you're not at a 1, I could usually tell most people, if it's like a really high blower door, that I bet that there's a wood-burning fireplace in the house, and it's one of those fireplaces that you can do from outside and inside.
Yeah, yeah.
And I've seen those by themselves leaking over 1,000 CFM just through the fireplace.
Sure.
And it comes through the stone and everything. Because,
Right.
again, it's not really designed to be...
Yeah, it's not meant to do that.
Yeah.
correct.
But usually if somebody insulates like that, in my opinion, you should be right around a 1 air change an hour. Some of these homes, to get to the Hearst 42, need blower doors at 0.5 air changes an hour. Yeah, because they have so many windows and whatever. So that case, they usually have to spray foam everything and do the aero barrier to get down to the 0.5.
So air barrier is spray foaming everything.
Nope. Well, that's just the type of insulation package that should get you to a 1 ACH.
Okay, so that's
Yep.
so that's a design rather than a physical product.
Exactly.
Okay.
Now,
aero barrier is what?
so aero barrier is a patented product that basically it's a water acrylic based sealant that is aerosolized, so it looks like a fog or a mist. And they basically take the home or the apartment and you pressurize it with a blower door to 100 pascals of positive pressure. And then the heads let off the sealant, and that sealant, since it's under such pressure, gets pushed into anywhere that there's an air gap. So basically all the little gaps, whether it be rough openings around windows, bottom plates, top plates, wherever there's air leakage, the sealant will go to. So
And you can see the results real time?
correct. So they're able to watch in CFM, cubic feet per minute, of how much the house is leaking. And then they'll know ahead of time, hey, this house needs a 300 CFM blower door, and it's starting at 800 CFM. And they'll watch, and the number goes down, they'll seal it down at 250 CFM, then break it down, clean up, and then at that point, you're sealed below where you need, and the key is that the builder maintains their air tightness, because you can have subs come in, punch holes in the envelope
Yeah,
after
so
that.
So ideally, in that scenario, all our penetrations are completed. We're done whatever insulation package we're gonna done.
Yep.
And our plaster board or drywall is hung and finished. And then we do the aero barrier
Correct.
before finishes are installed.
And most importantly, before flooring gets installed.
Oh yeah, I can imagine
Yeah.
that.
When
'Cause
flooring's installed,
that
it's-
acrylic's gonna stick to that flooring and it's done.
that's the one place where the sealant settles. I tell people, if it's the rough floor, great,
Yeah,
all good,
yeah.
doesn't matter.
Yeah.
But anything like that that's in, then it's just a lot of prep, so the price goes way up. And I
Right.
generally tell builders that I don't think it's financially worth it to do it after the fact, right? Either
Yeah,
do
it's
it.
too hard to prep it.
Right.
Right. So so one of the things I learned from yourself when I was doing my last larger project in Falmouth, and I wouldn't say I was nervous about reaching the blower door, but I wanted to ensure that I did. Is you said, hey, have us come in and do it when you're at plaster, and we're gonna quote unquote prove,
Yep.
that you're good to go.
Yep.
And assuming that no one drills any holes in the house after the fact, the electrician didn't forget to put something out, or dryer vent, or whatever that is,
Yep.
it's gonna stay stable with just adding finishes. Now, in that particular case, I did elect to have the aerial barrier come, because this was a personal friend of mine, and I said I want to get the air changes down as low as I can. And I want to say they sprayed about a gallon of that product, and it brought it from, I think, 1.6 or 1.7. We were pretty tight to begin with, and it got down to like 0.7 or 0.85.
Right. Yep.
So in a short amount of time, I think he was only there maybe 2 hours.
Yep.
And I was very impressed by that. So once that's done, that's permanent, right? Again, assuming nobody drills any holes.
Right. Right.
Yeah.
Yeah, and it should be. There's different things that come up. One of the bigger issues in like multifamily with apartments is like, we'll aerobarium down. And a lot of the air leakage, especially in multifamily, is all around the plugs, outlet boxes, switches, and it'll seal all those air gaps and where the knockouts in the back of the boxes. But then the electrician comes in to put in his final finishes, grabs it, right, jerks out the wires, which breaks the seal that was done, and then you lose some of the air tightness. And they do that to all of them. Now, all of a sudden, the house could maybe not be passing where it was before. So that's always where it's, an educational part with the builders to make sure that they understand.
So if you know you're doing that, right, it probably makes sense to pull the wires out of the boxes ahead of time. Now, just talking that through, it's not going to hurt anything. They're going to come out anyways to do the electrical finish. Right. And then do the aero barrier, and then everybody's just got to understand, leave the wires alone and let the electrician finish them off.
Right, exactly. No, a little detail change like that.
It's just little tricks.
Right, and that's a lot of it, especially like we do a lot of the aero barrier sealing for passive house projects because they need to get down to like 0.6 air changes an hour. Ooh. So now it's just, that's like a whole other animal. And in those type
so you really got to pay attention to the details and the sequence and who's coming and doing what. And when you're going to do things, et cetera. So that's interesting. So that's a whole science unto itself.
Yeah, because with the passive house projects, I basically tell the builders, and we set up where they either lease blower doors from us or they can buy their own, so that after we'll come out in a lot of the passive houses, because they have their exterior continuous insulation around the whole envelope, we'll seal them after that's in place, right? And then seal them down to 0.6 at that level.
So they're running their own blower doors, they're working.
Well, that's what I tell them they need to do to make sure they don't lose the seal.
Wow.
Because these subs, especially in a big project, they're savages.
Right.
So they're in there, they're doing their work, they don't care about air sealing.
Yeah, they're not thinking about it.
And if you don't have your PM running that blower door at the end or beginning of every day, you can't figure out what sub made the penetrations. So if you run it every day.
That's a real high maintenance build.
Yes, in my opinion, yes. And there's a lot of details that go into these passive house projects.
That would have never even occurred to me to have my own blower door on the job.
Because that way, then you're like, oh my gosh, we're up 500 CFM.
Yeah, 100%.
What happened? And then you can figure out, oh wait, these guys were here today. Let me go see what they were doing. And then you find it.
Yeah.
But if let's say
there's that big 2-inch hole he drilled for the whatever.
Right. But let's say it's a month later or 2 months later, you do the blower door. Never find it. You're like, I don't know what happened.
Yeah,
There's been so much work.
You can't unravel that.
So now you're searching. You're trying to find it. Infrared.
Smoke machines.
Yeah. But that is the worst way, in my opinion, to try to meet your air tightness levels. So yeah, it can be a little tricky.
Yeah, that's good. All right, so we're going to pivot off ADUs, and now we're going to go to new construction. Single family home. We're just going to do single because that's mainly what we concentrate on here, right?
Yep.
There's obviously multifamily, commercial, all that, but that's a whole separate meeting, and that's not really what we talk about much. So single family homes, now we're at 42, 45.
Yep.
So 42 is mixed fuel and 45 is all electric?
Correct.
So 42 is hard to get to.
Yeah.
Right?
Generally, yeah. I tell people for a single family home that we're going to frame traditionally and go with just improved double pane windows, the max HERS rating you'll generally see, the lowest will be like a HERS 40.
So if everything's perfect.
Everything's maxed out. The best gas equipment you can get, highest efficiency, really good, the best double pane windows you can get. R37 walls, R60 roof line, blower door under 1 air change an hour. All that together and it'll be a 42 or a 41 and a half.
So really close.
Yeah, every one of these homes, it's like that close.
Now, and again, I have not done one of these, so this is just hearsay that I've heard, is that a lot of these houses are having to add the solar component in order to make the rating because of the design or the exposure or whatever. Is that a true statement?
No, but sort of. Is that what it is that, so the solar and which this doesn't really make a lot of sense to me if our goal is about decarbonizing the state, but the solar, for whatever reason, does not count toward your code required HERS score. So the 4542 has to be without solar.
You get no bump for
No
that.
credit for solar at all.
But I'll get a bump for putting in for the wood timber bat.
Right. That's the carbon credit, right? And they did add that. So
they skipped solar,
right,
but they gave us 2 on timber bat.
the carbon credit, yeah, carbon credit.
All right. So if anybody's listening that's in charge of that bump, we need a bump for solar.
It makes sense to me because we're now, promoting all these all-electric homes, nonetheless, a lot of electric vehicles, right?
Right.
If we don't have solar on all these new homes, where's the power coming from? Right. And that's why I think that they should be promoting that any builder that's willing to build a relatively energy efficient home with solar should get a huge benefit toward code.
Yeah.
But for whatever reason there isn't. So it is what it is. But there's now all these towns that have opted in to the opt-in stretch code. It's like Boston, Cambridge.
So it's town dependent.
Yes, and a lot of it are the areas around Boston. It's like Wellfleet, Truro, and Eastham on Cape. Those have all opted in for the opt-in stretch code. And the difference of that is if it's all electric, single family, it's still HERS 45. But if you have gas in the house,
Any kind of gas.
for anything other than a propane fireplace, is you now...
That's new though, right? The exclusion for the fireplace?
Right, yep, is that it's just technically heating, hot water, and cooking, that it can't be.
And a backup generator is excluded, right?
Yes, you can have backup generator, and I think technically you can have gas for outside the house. You can have propane for outside.
Yeah.
But we were just saying that...
Well, you were taking me down that pain funnel of, it's all electric.
Oh, yeah, so now, if it has mixed fuel, they have to get to 42 without the solar, which we talked about that challenge. But then, if it's under 4,000 square feet, they have to do a 4 kilowatt solar system installed. If the house is over 4,000 square feet, they have to do enough solar to get to HERS 0.
So net zero house.
Net zero, if they have gas. If they go all electric, they don't need it. And that's what you're sort of
So one gas appliance is going to kick that off.
Yes.
Wow.
Right. And then also in those opt-in towns, anything that is a multifamily or it could be a single family, but something that's 12,000 square feet or larger, the only path for code compliance is passive house certified. And that's in Boston, Cambridge, all those densely populated area where, in my opinion, they do a lot of over 12,000 square foot stuff.
Yeah.
So now, at 0.6 air change an hour, continuous insulation, all these things are code mandated.
So it's pretty hard to get a 12,000 square foot custom home to make that go.
Right. And even more so, like a big apartment building.
Oh yeah, that's even worse.
That's where it's even harder because there's just so much going on.
It's price constrained and budget constrained, and repetitive construction, all those things. Probably not the highest quality materials everywhere, right?
And what's the cost that now you're doing all these added things on top of the insulation, triple glazed windows?
Yeah.
You now have to have blower doors on site. You gotta have someone who's going to run those every day.
Yeah, and you're going to have really low air changes, so you got to worry about the accuracy of the people, and we're going to get to that in a second. Is the air changes. So under 4,000. Let's repeat that. So under 4,000 means what on a non-stretch code opt-in town?
Non-opt-in town, it's just a HERS 42.
Okay.
It's the opt-in towns is where the solar is mandated.
Yeah, but we can't. And that under 4,000 non-opt-in, can we have a gas stove if we can make the house work?
Yeah.
Okay.
We can have gas everything.
We just got to figure out a way to make it work.
To get to the 42, right.
Which is tough to do once you add that gas component.
It can be, especially if like the windows are already purchased and they didn't get improved glass.
So again, it goes back to whatever you're planning on doing, talk to Andrew first, way before you buy anything, and almost at the very beginning of design, at least concept plans, to say what's the dream, this is where it's going to sit, this is the orientation, this is where the house is, this is the town, what's the code, right? All that's in that mix in the very early stages. Probably save a lot of heartache down the road.
And it's also like what's important to that customer, right? And that's like what matters a lot. Like some of the people are like into energy efficiency.
Sure.
And so maybe that customer is like, oh no, I want the triple glazed windows. I think they're great, blah, blah, blah.
Yeah, and I don't want gas, and I want all hybrid.
Right. Where I have a lot of other customers that'll be like, triple glazed, like it's the same view as what I see out my double pane window. Like they're there because they want the beach view, right? Or and they don't necessarily care about the energy efficiency. So that's always like, hey, that's cool. If you don't care about it, no big deal. Then we'll figure out what we can do.
Move it around. It's a chessboard.
Right. Exactly.
So now you take that same house, and now it's the opt-in. Now what do we have to do?
42. But then if it's over 4,000 square feet, you have to give another HERS rating that has the solar added to it, that's a HERS 0 or negative.
So you have to put solar on at that point.
Correct.
So if you're 4,100 square feet, so I'm thinking there's going to be a lot of 3,999 square foot houses, right?
But they then still have to do 4 kilowatt solar systems, so you are still doing solar.
Oh, okay. So no matter what, you're doing solar.
If you have gas in the opt-in
Okay,
towns.
all right,
Yeah.
okay. Okay, got it, okay. No matter what, all right. So now, so that's that scenario. And then you said the kickoff is what, 12,000 square feet or bigger?
For the passive house.
Right, so if you want to build a 12,000 square foot house in an opt-in town, it's got to be passive house rated.
Yeah, certified, right.
Certified, which is really hard to do.
Right. Like generally, like to do the rating on a regular single family home is usually around $2,000.
Yeah.
Or to do the rating of a
For
passive
your
house.
fee, you mean?
Yeah, for a passive house project is like $20,000.
Really? Just
That's
the
just
amount
for
of
have the
design.
rating. That's not even doing the build.
Yeah. just to do the design and figure it out and make it work.
And all the
On
testing,
paper.
it's an extensive amount of testing.
Ah.
And there's a lot of layers to it where even to the point where like water lines can only be certain diameters to maximize hot water distribution
Really?
and loss. And
Wow.
yeah, so there's a lot that goes into these passive house projects. So I generally tell builders, I'm like, if you haven't built passive house before, like you may want to bring on a consultant or someone to help you with this first one.
You definitely need an expert in your corner, right?
Yeah.
And someone's going to coach you through it, or you're going to make some expensive mistakes.
Well, and you get to the end, now it's done, and you're not passing your blower door.
You're in big trouble.
What do you do?
Yeah, I don't know.
And that's like in the past, we had projects that brought us in because they were failing their testing at the end, and we were trying to help them get their blower door down. A few of them we were able to figure out ways to get it down. A few we weren't. Luckily, it wasn't code required. So they just didn't get whatever incentive they were going to get from the city.
Or whatever that was, yeah.
But they could still occupy and move on.
Right.
Well, now it's attached to code, so I don't know if you can't occupy. I don't know how they.
So that's a nightmare scenario.
I would think, yes.
Yeah, for everybody.
Right.
Owners,
100
builders.
unit building you can't occupy. What do you do?
That hurts just talking about it.
But I got to believe that happens. There's going to be some sort of exemption they give that maybe comes with a fine. I don't know.
Yeah. Well, let's hope we never find ourselves in that scenario, right? We'll cross that bridge. Hopefully, we'll avoid that and never have that conversation.
Right.
So one of the things I've seen a push, I'm going to switch gears now, and we're going to talk about indoor air quality.
Yep.
And I know we had this discussion off camera, but we're going to start it again. So we've got a 4,000 square foot house. It needs a whole house ERV system.
Yep.
Energy recovery ventilation. I'm just going to pick on ERVs for now.
Yep.
And as you said, the scenario is, I'm just going to pick on a Cape house that's probably minimally occupied during the off season, right? Maybe 1-2 people, maybe nobody.
Right.
Right.
Maybe nobody.
And then come summertime, everybody's there, air conditioning's cranking, right? Food, cooking, dishwasher, laundry, all that's happening.
Right.
The problem is, as you stated, and I'll let you restate it, that an ERV was based on a static formula that said the house is this much square feet, and based on the air changes per hour, this is what we need to do.
Yes.
But it doesn't take into account the occupancy load or what's going on in the house.
Correct.
And so I'm gonna tee that up for you and let you run with it.
Yeah, so that's been, now that all these homes are coming in at like 1 air change an hour, in some cases less than 1 air change an hour, the ventilation becomes critical, in my opinion, and that we're already seeing, especially after this last winter was a pretty cold winter for, I live on the Cape, so for the Cape it was a little abnormally cold. But because of that, my opinion is creating condensation and moisture issues in these really tight homes. And the problem is the colder it gets outside, you're creating dew points. And the common dew point.
Explain what a dew point is.
Yeah, so the dew point is that for any temperature and humidity that an air has, there's a temperature that's a dew point for that air. And there's like a chart that you can look up and say, hey, if we have 70-degree air that's 50% humidity, it needs a 42-degree temperature surface that it'll condense on. So
that's what caused, when you open a wall and you see water running down inside a wall, that was the dew point. It hit the dew point by hitting that outside cold wall.
exactly. So like in that assembly, the dew point is commonly the back side of the sheathing.
Sure.
Because all you have is, some house wrap and siding on the outside. So there's maybe an R1, right, in that assembly. So if that air from the house is able to get to that sheathing, it'll commonly turn to water and then sometimes freeze and then just keep reoccurring all winter long. If somebody doesn't open up the wall cavity, usually that's just going to go unnoticed for a long time till all of a sudden somebody's like, why is this wall wonky?
Yeah, or the paint's all peeling off.
Right. And then when they investigate, they find out there's a serious moisture mold problem now.
Right. That's when there's one little hole and the guy sticks his finger in it, and it gets bigger and bigger and bigger and bigger, and next thing you know, they're ripping the house apart.
Right. So that's why I believe that the ventilation formula that we use is an ASHRAE calculation that's based on number of bedrooms, square footage of the home, and then also has a blower door air tightness that it accounts for too. So the tighter the blower door is, the more ventilation it says it needs mechanically. But the problem with this is that it's assuming a lot of things about that house. Like Buzz and I were just discussing, it's a 5-bedroom house, so it's assuming that 6 people are living there year round. And therefore it'll say in its calculation that, this house needs 140 CFM of ventilation 24 hours a day. So that 4,000 square foot house may have 2 ERVs is probably what I would recommend, one for the second floor, one for the first floor. But in that case, they're both, say, running at 70 CFM 24 hours a day. Well, what about when everyone goes to school or work? Or what about if it's not 6 people living in that house, it's just 2 retired couple?
Yeah.
Right? And they eat out every meal.
Yeah, or they're gone for 6 months out of the year.
They're snowbirds, right?
Yeah.
They take off. So but as it is currently, we just let the ERV run the whole time they're gone. So in my opinion, it wastes energy. And I think the way to do it properly is this, what I've been using in my house is this Broan Overture product.
Okay.
And basically what it is, it's an indoor air quality monitoring device that this is plugged in my living room, kitchen, dining room area, and it monitors humidity, CO2, airborne particulates, and total VOCs.
Really?
Yep. And it
All in that package?
all on this one box. And you see it's just a plug-in that you can plug into any outlet, and it even keeps a plug on the front of it so it doesn't waste the outlet. Like you could still use it, right?
Oh, so this is not a hardwired piece of equipment?
Nope, that's the plug-in. Now, they have a hardwired,
Sure.
but I didn't know about this when I built my house.
Sure.
So the plug-in
So this is the
works,
retrofit.
Right, works great. And what's neat is, so it talks to my ERV through Wi-Fi. And on your app, it'll show you those 4 pollutant levels inside your house.
Right?
App for everything. So at any time you can look at it and see the levels. And you can look over like, the past year, like what are things that cause it to
Also
spike?
keeping a record.
Record of it too.
So, all right, slow down now, because this is interesting. No, this is great stuff. So, humidity.
Yep, humidity, CO2, airborne particulates, and total VOCs, which is total volatile organic compounds.
Really?
And that's what a lot of people with the spray foam are worried about,
Sure.
the VOCs.
Yeah, we just had that discussion.
And that's why when I put this in 3 years ago, I felt good that although my house is all spray foamed, I've never even had 1 part per million of VOCs in the house the whole time.
Right, because on the app you can see the readout.
Yep, all the time. You can see the levels.
Wow.
And then the best part about it is that not only does it let you know what's going on, is it also resolves the problem. So in my house,
it's telling that ARV, hey, speed up.
Or go on and off.
Go on and off.
So, like
so
right
nobody's
now,
there.
It's off right now.
Yeah, depending, right?
right,
It
in
may
my
kick
house.
on.
Right, in
yeah,
my house it
All of a
is.
sudden, maybe the sun comes out and you get some extra kind of moisture in the house,
Yep.
and it kicks on for 10 minutes, and it shuts off. It's not running all day.
It's generally, when you watch it over a period of time, that it's like we are the pollution.
Sure.
And that when
Yeah,
no
you're
one's
coming and going, running
when
the
no one's in the
shower.
house, right? You're in,
Yeah.
sweating, and the CO2.
Sure.
So like with my house, as soon as 2 people or more come home, the CO2 level goes above 1,000 and the ERV comes on. And
And
it'll,
what's the cost of that product?
it's I think around $400.
So pretty reasonable.
Pretty reasonable price point considering you know,
And
you're
that's
building a new house.
everything you need, the app, everything. There's no monthly fee for the app?
No, nothing.
Okay,
Yeah,
that's
yeah.
fantastic. So even if someone doesn't have an ERV,
Yep.
they could plug this in and monitor their indoor air quality.
Exactly. And for certain homes that don't have ERVs,
Yep.
this is what I set them up with. So Overture also has this smart switch, right? So basically what this does is you would put this in the nearby bathroom, right? So then the Overture is monitoring in the living, kitchen, dining room.
Got it.
Communicates to this that if CO2 goes high, it turns the bath fan on to get the high
Really?
CO2
Okay,
out
so
and
we're-
bring it in.
It's not an ERV, but at least we're getting the bad air out of the house.
Getting ventilation
Sure.
and when you need it, not just all the time.
Yeah.
Right, because that's what people would drive people crazy with the old code.
Yeah, I know. I had a lot of customer complaints about that fan's coming on 6 hours a day and running. It's on a timer. And even though it's a Panasonic, what we were using, they're super quiet. But if you're laying in bed at night, you're gonna hear it.
Oh yeah, right. And that's why, for me, I have it set up where it's just the ERV and this communicate, but you can take it to the level where your range hood can have this. So if you start cooking and a bunch of particulates come
Sure.
up, it turns the range hood on.
Ah.
Let's
So
say,
there's modules that plug into this to say, hey, turn this thing on.
yeah, and so you'll have the main device, which is like the main brain that's
Sure.
communicating it all, but depending on which location it picks
Oh,
up.
so you can have multiples of this Overture. What is this little
The
switch
plug,
called?
yeah, the Overture plug basically is an on-off switch that can then be communicated to turn anything on or
So
off.
this is a smart device that can be controlled by that main brain.
Correct.
And what's the cost of this little one?
I think it's like $200 or under
Okay, so-
$200.
So you can do your house somewhere between, if you have an RV, $400 to maybe if you don't have an RV and you're worried about indoor air quality, maybe $600, $650, in a little bit of time.
Right.
And now you can control your bath fan or your hood fan or whatever it might be as a way to exhaust whatever the bad air you want to get rid of.
Exactly.
And it's smart because it's just not running all the time.
You're not wasting energy, you're ventilating when you need it. And the most important is you can look back at it and be like, what is going on at this time of the day
Sure.
that we have this really abnormal spike?
Yeah.
And you may find out, oh, that's when we're cooking and the kids are showering and all these things
Sure.
are going on at the same time.
Yeah.
And it just teaches you to understand these super tight homes better, in my opinion. Plus,
And they make a built-in version as well as a plug-in version?
yeah, there's a hardwired that a lot of our builders use now.
So that looks more like a thermostat type
Exactly.
scenario?
Little white rectangular
Okay.
box that maybe sticks out a half inch.
So this is a retrofit to plug in, and then you can hardwire in from the beginning that unit and have it so it's seamless.
Yep.
And generally put that somewhere near the thermostat, or
Yeah, so let's say
what's the best spot for that unit?
I tell people you want to pick what your most important spaces are.
Okay.
So let's say it's a first floor system. All right, we got the system in the basement,
The
ERVs in the
ERV,
basement.
yeah, ERV is
Then we'll have this Overture unit be in that main kitchen, living room,
Got it.
dining room area where you figure most people are going to spend most of the time there.
Sure.
You have guests over, everybody's going to hang out there. Because that's when you really want it, and especially if you're using the Brone ERV with it, it'll toggle between the speeds of the ERV
Yeah,
as
it'll
well.
ramp it up.
Right.
Ramp it up.
So you get a little bit above 1,000, it may come on low. But when there's 10 people over and you're 2,000, it's running at high. So it just makes sense to me, right? That it's
Wow.
you ventilate when we know that there's pollutants in the space, but we don't need to when there's not.
Got it. So that's really an interesting technology, and
Yeah.
again, hats off to you. Every time I meet with you, I learn something new. So you're a wealth of knowledge. Any parting thoughts on this subject? Other things we haven't talked about you want to hit on?
No, it's just basically like we've talked about forever. It's always been, hey, build it tight, but ventilate it right. And that's generally
Words to live by.
Right, that's generally what is I'm worried about that happening. Because over the years, you talk to different homeowners, this and that, and I'm explaining ventilation in these super tight homes. For some of the people that don't understand these super tight homes, a lot of them say to me I think that's stupid. And I'm like, all right, you can think whatever you want. Do whatever you like.
Now, it's
But-
funny. So I was a very early adopter of energy efficiency. In 1986, I used the first ICF concrete forms
Wow.
that I bought out of a 3-decker in New Bedford or somewhere down there, and the Halifax Country Club members lounge sits on insulated concrete forms.
Nice.
So very early, and then I did probably 88, 89, I did 1-inch ISO on the outside of a house for that continuous insulation. So very early on. So I've always, been super interested in stuff, embraced it, learned a lot on the way. I learn more every day. There's a lot to learn. And the biggest thing I've learned is to make sure to find the right expert.
Right.
So there's a lot of so-called people that think they know what they're talking about, and then there's people that know what they're talking about. So, just because someone tells you it's true, unless you really know them, that's the thing I like about dealing with you, is I know what you're telling me is real world. So I appreciate that. So now we're going to go into the rapid fire.
Sure.
All right?
Yeah.
So favorite tool you can't live without, and it can't be your phone.
I would say the blower door.
There you go.
Yeah.
I can see that.
Blower door and infrared.
All right, dream project you'd love to work on.
So I already have designed in our modeling software another house that I want to build.
Oh, your own house. Okay.
Our own house. So
You got
me
it
and
on paper.
Yeah, me and my wife built the one that we live in now, but that was now 7 years ago.
Sure.
So I feel like I've learned a lot, and that's when you're like, oh man, I could have done this so much
Yeah,
better,
yeah,
and this and that. And now with the housing market being insane, it's like, well, if we could sell this, and so we have a whole plan and a lot lined up that we may look into getting in the next couple of years.
Okay.
So I would love to do that build again, now knowing all this, and I feel like I could be able to, between the heat pumps and the second floor
Sure.
being too hot and the ventilation
Yeah,
and all
yeah.
these factors,
Yeah.
I'd really like to do another one.
All right, good stuff. I like that one. Best piece of advice you ever received?
Jeez.
This is you're in the hot seat now.
Best piece of advice I ever received. I would say, do what makes you happy. The things that you choose to do the majority of your time with, make sure you enjoy it.
Yeah, amen to that. And advice you would give your younger self?
Work harder. I was a slacker when I was younger. It's easy. You want to hang out with your friends. You want to go out to the bar. You want to do all these fun things. You want to go meet girls. Da da da. But when you're young, if you buckle down, like look at where Jesus is, and he's 10 years younger than me, and he's got a conglomerate that he runs.
Yeah,
so.
he's got a big operation for sure. So again, Andrew, fantastic having you here. That's a wrap today on this episode of the BuildX Podcast. Thank you, Andrew. Fantastic. From Home Energy Raiders, we will display your phone number and all your contact information. Please subscribe and like if you enjoyed this, and we'll see you next week. And remember, just build, baby.
Thanks so much, Buzz. It was a pleasure.
Awesome.